In example 9, we're going to make a frequency distribution for a set of data. Taking a look at the numbers that we have in our set of data, they're all fairly close together. I'm going to make an ungrouped one, right? So I'm just going to list each individual x value, but only once. I'm going to do that in the left column. So my data values, generally refer to those as our x values. And the different x values we have here go from 0 to 4. So I'm going to list them just once. And in the other column, I'm going to list the frequency. So I'm just going to count how many times each one of these values appears. So 0 occurs just once, right there. So I've got that one accounted for. The ones, how many ones do we have? We've got 1, 2, 3, and that's it. So that takes care of those. For twos, we've got 1, 2, 3, 4, 5, 6, 7, 8 twos. For threes, let's see, I've got 1, 2, 3, 4, 5. 5 threes. And how many fours? 1, 2, 3 fours. And so this is a frequency distribution. We're just listing each value that appears and then indicating how often that value appears in the other column. Now, when you make a frequency distribution, you have a bit of a check just to make sure that we didn't miss anything or maybe perhaps double count a particular value. If you look up here in the original list, we had 20 values, right? So there's rows of 10 each, and we have 2 rows. So there are 20 values listed, 20 data, and of course this is our n. We say n is equal to 20. And if you add up the frequencies, and if we want to talk about adding up the frequencies, we use this little bit of notation here. The sigma notation means add up everything that follows. So this means the sigma f means add up the frequencies. And if we add up the frequency column, let's see, we should get, that adds up to 20, and that should always give us the total number of data.